and today I'm going to represent stance detection feature as part of Alternus Vera project. So what is Alternus Vera and fake news? So fake news is nothing but news which is made up story with an intention to deceive reader or grab reader's interest. And Alternus Vera is the project that helps us identify whether a news is fake or not. So what is stance detection? Stance detection is a method which is used to determine the quality of a news article by taking into consideration what other organizations write about the same headline. So, a body of text is claimed to agree, disagree, discuss, or be unrelated to headline at all. So the goal of this project is to automate this stance detection since it is not practical for humans to fact check every piece of information produced by the media. So uh, I already discussed four different stance types, which are agrees, disagrees, discusses, which is neutral, and unrelated. Let me quickly go through the dataset that I'm using here. So there are two different CSV files that I am using, and this data set is provided by fakechallenge.org. It contains so the trained stances file contains a headline and related body ID, and the stance whether the body and the headline agrees or not. So let's quickly check the body ID in train bodies file. So if you see here, 712 says Danny Boyle is directing the Untitled film, which is not at all related to the headline given here, and hence the stance is unrelated. So train stances contains in total 50,000 such different records. Now we will walk through over the code. So yeah, it starts by reading the data sets of train bodies and train stances.csvs, and then the entire all the body IDs are divided into three different sets called training IDs, dev IDs, and test IDs, which I will be using for training the model later on. So yeah, the very first step is loading the dataset, and the next step is to extract the important features. So extracting features is a big process. It first starts with running the TF-IDF vectorizer on body and headline, so we can get some features. As you can see here, I have identified top 10 features with lowest IDF and top 10 features with highest IDF. So basically, these are the words like said, told, people. They are frequently occurring words in many documents. So basically, the weight for them is penalized, and uh, they have the lowest IDF. And these are the features with the highest IDF. So as you can see here, I have used n-grams of 2. So basically, two set of consecutive words can appear at the same time. And these are like a token which is appearing just in one of the documents. So they have the highest IDF here. So once TF-IDF vectors are extracted for all the bodies and headlines, I am extracting the word overlap. Word overlap is nothing but pre-processing the text. So as you can see here, there is a text function, text pre-processing function, which does the tokenization, stemming, lemmatization. It removes the non-alphanumeric words. It converts everything into from capital to lower and returns you the final result or final tokens from the pre-processing portion. So once word overlap is extracted, we start with extracting the Cosine similarity between body and the headline. So this is the function, this is the formula to get the cosine similarity. You are basically taking the TF-IDF and multiplying the transpose of TF-IDF with that, and convert the entire cosine similarity into Cosine array and return that Cosine array to the function. So yeah, that is what is done here. And once the cosine similarity has been extracted, all the combined features are written back at the end. So now we have basically three different arrays or list that contains uh, that those are nothing but sparse metrics that we have got after extracting all the features. So we'll use them and pass it to our model for the training and prediction. So yeah, here comes the model. So our stance is our target variable, and the features that we just got is our training data. So I have run three different models here, which is logistic regression, random forest, and multinomial naive Bayes. So logistic regression is done with LBFGS solver because that is what is used for multinomial logistic regression, where you have multiple classes like we have here. So accuracy with the logistic regression is almost 90%, and this is the classification report and confusion matrix for the same. So if you see here, it is a very good algorithm. But yeah, let's before jumping to conclusions, let's move forward. With random forest, we are getting almost 80% accuracy, and with multinomial naive Bayes, it has dropped drastically to 43%. So yeah, this is the combined statistics or accuracy scores for our algorithm. And as you can see, logistic regression does the best job in identifying the stance, followed by random forest and naive Bayes. So we can use, so to conclude, we can use this model and combine it with our Alternate Vera project to identify whether a news is fake or not based on the stance that we have just detected. Thank you.